holes, we can learn more about the formation and evolution of galaxies. Black hole mergers can also be used to study the expansion of the universe. By measuring the distance to the galaxies hosting the merging black holes, scientists can determine the rate at which the universe is expanding. This information can help us better understand the history of the universe and its ultimate fate. The detection of black hole mergers has also led to the discovery of new astronomical objects. For example, the merger of two neutron stars can create a kilonova, an incredibly bright explosion that emits light across the electromagnetic spectrum. The detection of a kilonova in 2017 provided important insights into the behavior of matter under extreme conditions. Black hole mergers can also have a significant impact on the production of heavy elements in the universe. When neutron stars merge, they can create conditions that are conducive to the production of heavy elements like gold and platinum. These elements are then dispersed into the surrounding environment, eventually making their way into new stars and planets. Black hole mergers can be used to test Einstein's theory of general relativity. General relativity predicts the behavior of gravitational waves, and the detection of these waves from black hole mergers provides a way to test this theory. The study of black hole mergers can also shed light on the nature of dark matter. Dark matter is a mysterious substance that makes up a significant portion of the universe's mass but does not interact with light or other forms of electromagnetic radiation. By studying the gravitational effects of black hole mergers, scientists can learn more about the distribution of dark matter in the universe. Black hole mergers can create some of the most energetic particles in the universe. When black holes merge, they can create jets of particles that are accelerated to near light speeds. These jets can produce some of the highest energy particles ever observed, providing important insights into the behavior of matter and energy under extreme conditions. The detection of black hole mergers is a significant achievement in observational astronomy. To detect the faint gravitational waves emitted by black hole mergers, scientists must use incredibly sensitive instruments like the Laser Interferometer Gravitational Wave Observatory, LIGO. The detection of these waves represents a major breakthrough in our ability to observe the universe. Black hole mergers can also have important implications for the search for extraterrestrial life. When black holes merge, they can create conditions that are conducive to the formation of habitable planets around nearby stars. By studying the mergers of black holes and other celestial objects, we can learn more about the conditions necessary for the formation of life in the universe. Black hole mergers can create some of the most massive objects in the universe. When two supermassive black holes merge, they can create a single black hole with a mass billions of times that of the Sun. These objects, known as ultramassive black holes, have important implications for the evolution of galaxies and the structure of the universe. The study of black hole mergers can also help us understand the nature of dark energy. Dark energy is a mysterious force that is causing the expansion of the universe to accelerate. By studying the gravitational effects of black hole mergers, scientists can learn more about the distribution of matter and energy in the universe and the behavior of dark energy. Black hole mergers can also be used to study the evolution of stars. When black holes merge, they can create conditions that are conducive to the formation of new stars. By studying the mergers of black holes and other celestial objects, we can learn more about the processes that drive star formation and the evolution of stars over time. The detection of black hole mergers has opened up a new era of multi-messenger astronomy. In addition to detecting gravitational waves, scientists can also observe the electromagnetic radiation emitted by black hole mergers, such as gamma rays, radio waves, and X-rays. By combining data from multiple sources, scientists can gain a more complete picture of these events and the impact they have on the surrounding environment. Black hole mergers can also have important implications for the search for dark matter. Dark matter is a hypothetical substance that interacts only weakly with normal matter and has yet to be directly detected. By studying the gravitational effects of black hole mergers, scientists can learn more about the distribution of dark matter in the universe and its role in the formation and evolution of galaxies. In conclusion, the study of black hole mergers is an incredibly rich and diverse field that offers important insights into many different areas of astronomy and physics. It provides us with a window into the behavior of matter and energy under extreme conditions, and has the potential to revolutionize our understanding of the universe. As we continue to study black hole mergers and their impact on the surrounding environment, we can expect to make many exciting new discoveries and deepen our understanding of the mysteries of the cosmos.